Hello, everyone. I'm Chemizu, but you can call me Mizu for short. And today we'll be talking about something interesting to developers, which is merge conflicts. So, what's a merge conflict? I'll start by giving an illustration. So, let's say you're a developer. Most of the time, you've written code, it's been in a place where you had all access, all superiority in the code base, and you could write the code only in one branch and push directly to main, or you had multiple branches, and in the multiple branches you could make changes, but you never did quite get to the point where you worked on multiple branches at the same time and had changes you made across the same file before merging to main. So we'll address that. Merge conflicts tend to happen in collaborative settings. So it could be like your workplace, it could be in an open source organization, or any just generally anywhere where you aren't the only one writing code. It could also happen in places where you are the only one writing code, but it would have to be across multiple branches. Now, what exactly is a merge conflict? A merge conflict is a change across a file or a series of files in multiple branches. Let's use two branches for simplicity's sake. In two branches that prevents a direct merge from occurring. So let's say you change something in one branch and commit that change, and in the other branch, you change that same line to something else and commit that change. When you try to merge both branches together, you would get a merge conflict. So it's not just about talking about how merge conflicts happen, but today's video will try and address how you can fix merge conflicts so that you wouldn't have to panic anytime you encountered one. So for this, I created a small GitHub project. It's basically just an alphabet.txt where the alphabets are written in uppercase and numbers, and there's a line above and below the alphabets. But to properly dig into it, let's see how this got to be. So there are five commits. This was how the file initially started. And these commits will be important. I just want to drop the information. So it started like this. Basically an alphabets in lowercase and nothing else will be here for now. And letters A to Z all in lowercase. So this was the first commit. And the second commit was by changing them to uppercase. So this. The third commit was adding numbers. So if you had A, the next number would be one. If you had B, the next number would be two. And at this point, I'm sure you're wondering, why am I using alphabets? Well, it's something that is programming language agnostic. It's a very simple way to create a good mental model about it without trying to understand the syntax of what is going on. And alphabets were like really easy. And then here, I just changed the nothing to something. And for this last commit, I changed the intro message because it was initially lowercase, so I changed it to uppercase and numbers. Now, I have a couple of pull requests, but all the pull requests were made of at the time of this initial commit. So every pull request, every branch I made followed from initial commit, but initial commits changed, or rather the code or the alphabets, right? The alphabet.txt file changed several times after the initial commits, but the branches I made all took off of the initial commits. So there are a couple of ways to solve, and I try to make this tutorial representative of the ways we could solve those errors. So there's this tool I use called the fork tool. It's git fork.com. It's very nice, very helpful. It helps to make visualizations of what you're trying to do. It makes things like squashing, rebasing, etc., really easy to do, and it's nice to reason about. I do not always use this tool, but I believe this tool is very beginner friendly, and it's a good way to get the picture of what you're trying to solve. Now, but before all of this, let's explain how Git merges work. or let's explain how branches work with reference to merges. Now, let's say when you start a project, the initial commit is A, and you make some changes, then you have B, you make some other changes, you have C. And let's say you split that branch into a different branch from C. So C is your head here. You make another commit, then you have D, another commit, then you have E. So these are two branches, but the branch on the right, that's EDC, is very much compatible with the branch on the left, that's CBA, meaning you could merge EDC into CBA. But that's just half of the story. What if you started from C, but along the lines in the main branch, you added another branch, D, not another branch, sorry, another commit, D. So now you have a branch that's spawned off from where C stopped at, and on the main branch, there is a subsequent commit from it. How do you go about that? Now, there are two important concepts to understand, which is merging and rebasing. In Git, I mean, we could look this up. When you do a merge directly, you're essentially adding a new commit. So if you were to merge this and this, your history would end up looking a lot like, let's see if I can change this. So if you were to merge these two branches, you would have let's say you're merging them to the branch on the left, you would have another commit D, where commit D is the merge of this branch by the right and this branch by the left. So merging directly, it's not exactly the greatest thing if you are very pedantic or careful about keeping your commit histories together. And to be honest, keeping commit histories together is very important for a lot of projects. It kind of paints a story, and it's easier to understand how um, changes in the code base progressed from where they were to where they currently are. But if you were to rebase instead of a direct merge, at the end of the day, they both achieve the same objectives. They make one branch's changes appear in the other branch, but it's the technicality of the how they do it. So if you are to rebase, rebasing means changing the base of the branch. So let's say there's a C here and there's an ABC. Let's say this is a new commit that has been made. And you want to, or let's just call this F since there's a D and there's an E here for simplicity's sake. And you want to join both branches, I'll use the word join. If you were to rebase, you would effectively be saying, okay, let this C here change to F. So essentially, you're saying, let's carry all our changes from this new branch and hold somewhere, then fast forward all the changes from the time of the split or like the deviation from the main branch into like we'll basically fast forward and then get the bottom of the extra branch we created, that's the new branch we made, and put on top of those. So the history would then look something like A, B, C, F, and instead of CDE, you would have DE. So this is what you would get if you are doing a rebase, and this is what you would get if you were doing a direct merge, right? So this is the difference between rebasing and merging. None is particularly better than the other, but if you care about preserving your history, it's good you just do a rebase more often than not. So yeah, enough talk about that. Let's look at the changes. So we'll start small. Let's look at this one, an example to be fixed on GitHub. Now, in GitHub, let's say you want to merge, it will first point you towards the fact that the branch has conflicts that must be resolved. Now, for like really simple stuff where it could be maybe typos or one line changes, you could get away with just fixing stuff on this interface and it becomes like really easy to merge. So here you can see that there is the current change, which is the change that was um wait, current change. Yeah, yeah. This is from our branch. This is how things look like. And this is what is coming from main. This is after all the changes in main have been done. So we looking at it now, you just want whatever you have to mirror what should be in main. So we could get away with fixing something as simple as this in the GitHub interface and removing what is no longer needed. After this, we can mark as resolved and commit the merge, waiting, and it has been committed. So if you look into the commit history, you see the initial commit we had and then the merge. Now you can merge, you can squash and merge, you can rebase and merge. Now, just like I mentioned before, with the merge commit, it does all of this as one direct merge. With a squash merge, the two commits will be squeezed into one. So, like if there are 50 commits, it will just serve as one one new commit and it would join main. But for a rebase, the history would effectively still stay the same. But we're not interested in merging now because if we merge this, any change we make would also be reflective of the other pull requests. Remember, we're here to fix merge conflicts, not necessarily to merge. So yeah, this can be considered fixed. So let's close this pull request. Right. Now that that's out of the way, let's look at the next one. A very simple merge where nothing should go wrong. Yeah, this is actually showing a merge conflict as a result of a mistake I made while doing something. But in reality, if I had left this as it was and tried to merge directly, it would have merged without showing an error. So this was a mistake on my end, but it goes to show that when you have a main branch and you have another branch and the change you make in the file does not alter any of the existing states of the file prior to the time you branched out, there will be no merge conflict. You would just as well be able to add new lines and text without having to worry about any merge conflict. So this was a last minute issue. We can skip this, but let's just resolve it. All right. Maybe I'll come back to this towards the end of the video and do a proper demonstration. Yeah, let's just accept incoming change. Mark as resolved. Yeah. Commit merge. The commit is for the branch we're on, not for like the central merge. Now we close this and we'll be back down to two pull requests. This is where things get interesting. So let's look at this one, an example to be fixed on the editor. Now, there are five commits that were made from the initial commit status of the project. And we'll just look at the commits. So the first one was to add a few words with arrows, like a letter, an arrow, and a word as an indication of what the what the letter can possibly start with. So we have apple, back, cats, very simple changes. Then include more letters here. I just added like U and zoo for letters Y and letter Z. And at some point I got bored and decided to add commas at the file itself. So apple, comma, B, arrow back, comma, C. Yeah, added commas here. Then I changed the last sentence. And just so that I could pile it up to five commits here, I made a random change. Honestly, cannot. Oh, yeah, yeah. I just added in uppercase letters A down to Z again. So assuming we were to try to fix this, Now remember, we're trying to merge the commits from main into this branch we have. And for this, I want to rebase. So this is where this is my VS Code, and that's me. This is where the project is. Oops, I'm about to sneeze again. I'll pause the video here. All right, I am back. I mistakenly ended the video because of my allergies, but I will just join them. Right, so we're on the GitHub. Oh, sorry, we're on my VS Code, not my GitHub. And we want to try and fix the the merge conflict that would be found in the editor. Like fixing the merge conflict that would normally happen, but fixing that in the editor itself. So let's first check out to the particular branch. Right, so this is where we are now. And remember, I talked about how rebasing saves you your commit history. And that's what I want to do. So there would normally be two ways I could do this. I could just do a direct merge, and it would show me what the issues are, and I could, of course, fix from here. But I'm not interested in doing a direct merge, so I will abort. What I do want to do, on the other hand, is to rebase. So to rebase this, I would basically pull now git pull origin, or if you are in a collaborative environment, chances are you would use the remote for whatever repository you got this from. So in the case where it's not the origin, are saved in like your Git remotes for the project, you would swap origin for whatever that would be. And I'm trying to pull main, that's the latest changes of main into my branch, which triggers an interactive rebase. Now, this is where it gets interesting. When you try to fix merge conflicts by rebasing, it does this by going through each individual commit. So essentially, what that means is all the changes in main would first pass through this commit, and then you would fix what is wrong in this commit if there are any issues. Then, after fixing that, it would progress to this commit, meaning the changes that you'd solved here alongside all the previous changes from the main branch would all show up here and try to fix whatever issues exist. Then after this, it would do this, then this, then this. So the thing is, if there's no merge conflict in any of these commits, that commit would just it would automatically be attached and move on to the next. So let's say theoretically, if the only changes that would cause merge conflicts were in this commit, after fixing the merge conflict in this commit, everything else would just work all together. So when you're rebasing, for every commit you have that has a discrepancy with the branch you're trying to merge into it, you're going to have to address any merge conflict that comes up, which is where a technique called squashing happens. So squashing means joining multiple commits together. It could be two commits, it could be three, it could be 10. There is no limit to the number of commits you could merge. So a strategy for some organizations that typically don't care about each individual commit upon merge would do is they would just merge everything into one commit, give it a name, and then rebase against that so that they would fix all the commit issues at once. And that would look a lot like if we were doing a direct merge, but the difference is it's not creating a separate commit for the merge. So it's better preserves your commit history, but it does not, aside that, it doesn't give so much more benefits versus when you are doing a direct merge. So another strategy you could do could be to like squash some. So I could get away with squashing these first two that are just adding letters and then fixing those and having the remaining three commits to be fixed. So, but yeah, enough chit chat. Let's get to fixing. So here is the first change. Now, mind you, you don't only have to remove this. Yeah, you could switch things up. You could copy something here, paste elsewhere. So let's say what I really want at the end of the day is to try to merge this here. Let's say Apple. Oops, oops, sorry. Yeah, space. Then we do the same thing for bag, but we use an uppercase B. Then we do the same thing for cats, but we do an uppercase C, right? So let's say this is all I want. I want to keep these changes, but switch them to uppercase and leave everything else as is. So now I'm done. I could essentially remove, oops, sorry, right? And then save. You can also resolve in your merge editor, but when you're done, you can either type the command git rebase dash dash continue, or you could just, oops, sorry, you could just add to the staging area and then continue. Right. So notice how it says 2 over 5. That's because there are 5 commits here. And the first one just got fixed. So now we are in the second commit. If there were no issues with the second commit, it would have jumped straight to the third commit. Then we would have had 3 over 5. So yeah, let's get that out of the way. Now we have this here. So let's again try to copy these changes. So it's essentially an arrow, then U, then an arrow, then zoo, then space. So let's assume these changes are enough for the purposes of our illustration. And then we keep this here, we save. You can, or let me just add, let me type the command manually and to show you that it works whether you're using your terminal or you're using your, oops, uh, um, let's, let's just continue here. Yeah. Right. So this is the third commit. Now this commit, it's also helpful to have like descriptive commit messages. So this one says add commas, and looking at it now, let's just say I'm not interested in the commas anymore. And notice how it says incoming changes despite being in the branch we are currently in. Now, mind you, that's because it is assuming that the main is the status quo, is the like universal source of truth. Therefore, anything else that is different from main is an incoming change. So let's just leave it at accept current change, save, add, continue. So now we're in change number 4. So let's see. Um, the incoming change says nothing will be here again, which is honestly fine by me. So let's say accept. Nothing will be here. Save, add, continue. Now we are down to the final commit where I'm like, okay, no, let's just um, leave it at the current change. Right. So we save, we add, and we continue. Now it tells us that it's actually been a successful merge conflict fix, but for things to work right, it's best we pushed. Like we need to sync the changes we have both on the GitHub repo, like where the branch is on the GitHub repo, versus what we have locally. Yeah, pull and push. Right. So it points to yet another merge conflict. And that's because, oh, yeah, we pulled. I should not have pulled. But yeah, we'll just fix it again. Accept incoming changes. Yep. Save. That's because it pulled five additional branches, which, you know what? Let's abort. Git abort. Sorry, git rebase abort. Now we're back here, and if we try to push, it would normally point us to the fact that there are some changes that do not quite make sense yet. So we could do right. So force release is a command that I had hoped I would introduce in the subsequent version, but it essentially means that yeah, that I've made some changes and those changes on my local machine are no longer in tandem with what I have here. So instead of pulling and pushing and making things funny, let's just safely overwrite. Right. So this this is what we will now have because it is representative of the changes. I'll type out the command I use for that. So you can either git push force or git push double hyphen force, or you could git push double hyphen force with this. It's a command that you could read up on, but it helps for like fixing merge conflicts locally and then pushing to wherever, like whatever the branch is being hosted on. So now, as a final example, we can look at the pull request that tries to use the fork tool, git checkout fix fork tool. Right. So this is where we are. And let's say we want to merge, right? Want to rebase. So this is the tool here. It might look a bit overwhelming, but trust me, it's so much easier to use than it looks. And first thing is to switch to the branch that we want to rebase changes onto, or is whose changes we want to rebase. And now we have main here. So since we're in the fix dash fork tool, we could right click and interactively rebase. So just by clicking this button, it makes it so much easier to reason about. Now, the actual changes would be made somewhere else, like in the editor. I've not used the editing interface of this fork tool, but like it gives you a good visualization. Now, let's say we want to squash. Yeah, so there's squash where you keep, like you meld the commit into the previous one and discard the message, or you keep. So let's say include more letters, suggest words that start with letters. Let's say I'll do a fix up for this because it's essentially doing the same thing, just adding letters but done differently. So you could do this, right? And um, after this, is there anything else I'd like to do? Let's say I will also do a fix up here, or we could do a squash and keep both commits, but let's just do a fix up. So now it's wait, did I save? I commit my changes, abort replace. Yeah, yeah, I did not save what I was trying to do. Right, so let's change that. Fix up. I like the idea of doing these videos as realistically as I can without like to give you a sense that this is real and this is not in any way like rehearsed, to walk you through my thought process and the fact that yes, the occasional errors are very much allowed. Doesn't seem to want to save. Um, let's see. Let's see. Um, please save. Please save. Yeah, you know what? Let's. Do I want to cancel? No. Do I do this? Yeah, let's just rebase. Anyways, so it shows the merge conflicts, and those will get reflected in your editor. So you can essentially fix these, continue. When you continue, it comes back here and does the work for you. Like it's it is a nice way of doing what we just did, but while having a nice visualization of what is going on. So again, I do not need to finish this here. Let's just abort and here, yeah, let's actively rebase. Nah. Okay, no, I don't need to fix all of this. Right. So yes, that is for the fork tool as a whole. Now, finally, we would have the reflog issue. So let's merge this now, but in a way that is a bit chaotic and like in a way that we would wish we could go back to what we had. So fix up, rebase, resolve. Let's just say merge and fork. Hmm. Or better yet, let's fix everything here. Let's say accept incoming changes, save, continue, continue. Yep. Accept incoming changes, save, continue, continue. Yep. Yeah, so it skipped from 2 to 4. Let's say accept both changes, save, continue. Right? Now, let's say we've done a lot of things that we did not want to do, and we somehow want to sort of undo these changes. Now, when you make changes or like merges that sort of remove some parts of the commit history, it can be very tricky to get back. But there's this useful command. Essentially, when you've done something really crazy and you need a way to go back and start from where you stopped at, there's this really nice tool called reflog. So it's the reference logs. It shows you all the changes you've made and how you got to that point. So from here, you could try to pick up. So let's look at what it says. This is where somewhere along here, this is where our rebase starts. Yes. And we abort, we rebase again, we abort, we rebase, and then we make all these changes. So if you are trying to return to a state where things were previously okay, you could start with, let's say, here. And we're like, yes, things look like they were okay here. So we can just swap back to this. So copy the commit hash. The queue should be okay. So git reset soft, voila. And when we come back here, we can just as easily unstage the changes and discard the changes we've made to the file. And bam, we fixed a reflog issue. So that's kind of the summary of all of this. With merge conflicts, there's no real reason to panic. You just need to like slow down, take a step back, try to understand why exactly the issue happened the way it's happened, figure out whether you want to keep your commit histories, and then slowly rebase. I would recommend rebasing over merging, although one is not necessarily better than the other. It just depends on what you are trying to achieve. Right. So thank you so much for watching this video to the end. Have a nice day. Cheers.